Hello friends, in this session we will discuss about data visualization and various plots. So as we know, visualization is also a form of communication to different plots, different charts. We can understand a very big data in few seconds only. And we can get the insight from the data by just looking on the charts and graphs. So the first chart which I'm going to use is bar chart. Okay. So here I'm using bar chart, and the dataset which I'm using is empty cars dataset, which is by default provided in our R Studio. So let's see what is empty cars dataset all about. So click on this. See, we have different cars, Mazda, Datsun. We have different cars. So in this way, we have 32 cars, 32 car entries, and 11 columns. 11 columns means 11 fields: mileage, cylinder, displacement, horsepower, weight, gear. So we have 11 fields. Okay, this is our empty cars data set. So we will use this data set. So firstly, I will use this table command. What this table command will do? This table command will give me a frequency distribution. So I want frequency distribution of cars from the empty car data set gear wise. That how many cars we have of how many gears. So let us suppose we have 3 gears, 4 gear and 5 gear cars. So how many car of 3 gears, how many car of 4 gears, and how many car of 5 gears. So if I run this line of code, if I run this, so it will come in counts. Okay. That frequency which table command has created, table function has created, it will come in count. Now I want to create a bar plot. How to create a bar plot? You have to type bar plot bracket counts. Okay, the count. And if I run this, now see, we have uh, around 13 cars of 3 gears and around 12 cars of 4 gear and around 5 cars of 5 gears, like this. Okay. If you want to see your bar plot horizontally, you have to type horizon is equals to true or horizontal is equals to true. And if I run this, we can see it horizontally. Okay. If you want to see the bar plot according to the mileage of cars, so if I run this line, now see, all these are 32 observation. All these are observation of 32 cars and how much mileage they are giving. Now the first car is giving around 16 mileage, again 16, then around 20 mileage, third one. So there are different cars of different mileage. Okay. So in this way, if you want to see how many cars of different cylinders we have, so I have taken this variable. Now you might be thinking why I have used this dollar sign. See, to access particular variable from the data set, we have to write this. Like our data set is empty cars. If I put dollar over here, oh sorry, spelling mistake, empty C-A-R, empty cars, dollar. Now it will show me all the variables in this data set. And now if I want cylinders, so I will click on the cylinder. Now if I run this, now see, cars with different number of cylinders. Now first car, this bar, these are called bins. Okay. So the first bin is with 6 cylinder, another car 6 cylinder, third car with four cylinder. Okay. In this way, we can see the distribution of all the 32 cars, 32 observation. Now, again, I will use the table command to see how many cars uh, we have of different cylinders. So if I run this line, table empty car cylinder, if I run this, it will show me that 11 cars I have with 4 cylinders, 7 cars we have 6 cylinders, and 14 cars with 8 cylinders we have. Okay, and I have assigned the output, this output which I received, this output I am assigning it to table 1 variable. Okay, table 1. So let me run this. Okay, so table 1 I have. Now I'm creating bar plot. Bar plot with table 1. Okay. table 1 I'm having this frequency, 4 cylinder 11 cars, 6 cylinder 7 cars. So table 1. Then I'm giving legend as well. Legends will be row names. The row names will be 4, 6, and 8. So these will be my legend names. I'll tell you how. What are the legends if I run this command? Now see, 4, 6, and 8, and this is our legend 4, 6, and 8. So I have given legend names 4, 6, and 8. I have given from row names. Okay, I have given this command. Legends will be row names from table 1. 4, 6, and 8, they come up with the legend names. We can change these legend names. We'll do it later. Okay. Now, if I remove this line, legend row name, this if I remove this and run this command, legends will not come. Now see, legends are not coming. Okay. Now we can add now multiple things like I want to give name to this graph. Now we have no name here right now. So to give a name to the graph, we will write main. Main is equals to in double quotes, whatever you will write, it will come as the name of the graph. Then xlab. Xlab is x label. For x-axis, what do we want to give as label? And in y-axis, what will be the label? So in x-axis, I want to type number of cylinders because 4, 6, and 8 are number of cylinders. And then we have y label. Y label, I'm giving frequency. And again, legend, again, I have given table 1, but I have added color as well. So how to add color? Color is equals to COL is equals to C. Concatenate the same as we write when we create vector. Red, blue, and green I have given. So respectively, red will be allotted to 4, blue will be allotted to 6, and green will be allotted to 8. Okay. So color distribution. Now if I run this, now we can see this graph of cylinders, red, blue, and green. And these are legend 4, 6, 8. We can see name of the graph of cylinders, x-axis number of cylinders, y-axis our frequency. Okay. Now, if I want to see how many cars I have with cylinder and gears, so again I will use table function for frequency distribution. So empty cars cylinder and empty cars gear I have given over here. Now if I run this, what will be the output? Now this is the output. This 3, 4, and 5, these are my gears. 4, 6, 8 are my cylinders. And this data 1, 8, 2, 2, 4, 1 in this matrix form, 12, 0, 2, these are my cars. Means I have 8 cars with 4 gear and 4 cylinder. I have 1 car with 5 gears and 6 cylinder. I have no car with 4 gear and 8 cylinder. So I got this frequency distribution and I have assigned this frequency distribution to a variable named table2. And now I will create a bar plot. And if you want to group the variables, okay, so to group the variable, we write beside is equals to t. T means true. If I run this, you will see grouped bar plot. Just a minute, table2, and then nothing. Grouped chart. Here we don't have anything, any means for 4 cylinders, for 4 gear, 8 cylinders, there is no car. See here, 4 gear, 8 cylinder, no car, 0. That is why we have 0 over here. So this is how we can create bar plot. These are the basics of the plot we are discussing in this session because we are starting from grassroots level. Might be at this stage you find these graphs are not of international quality or standard, but later on, with while we will when we will use ggplot to grammar of graphics package, then we will create beautiful graphs. So after this bar plot, we'll use create a pie chart. Okay, as we all know, The pie chart also shows the proportion percentage wise. Hmm. So to create a pie chart, you have to write only pi, and I have given values 1, 2, 3, 4. Create a pie chart with these values. Now these are not only values; these are percentage, the area which it will cover in the pie chart. One means if I calculate all these things, 4 plus 3, 7 plus 2, 9 plus 1, 10. Out of 10, 1 is 10%, 2 is 20%, 3 is 30%, and 4 is 40%. We will see uh, the area in the pie chart. If I run this line, now see this is pie chart. 1 means 10%. Now we can see how much area it is covering, only 10% of the pie chart. 2 means 20% of the area, 30%, and 4 means 40% of the pie chart. In total, it is cumulative, it is 100%. Now, I'm adding labels to it. Right now, labels are coming 1, 2, 3, and 4. So I'm adding labels also. Labels is equals to C, A, B, and C, D. Now, instead of 1, 2, 3, and 4, my labels will come as A, B, C, and D. If I run this line, we can see A, B, C, and D. Okay. So now I have saved these values in a vector called X. Now, X is having values 1, 2, 3, 4. And for labels, I have created a different vector. Now, my different vector is Y. For labels A, B, C, and D, character type vector. Okay. Now I need to convert the value of X in percentage. So 1 is 10%, 2 is 20, 3, 30, 4, 40. In total 100%. So to create to find out the percentage, there is a simple mathematical formula. So the value will be divided by sum of all these values and multiplied by 100. So this is a simple mathematical calculation to find out percentage. So first time what will happen, see sum of X is 10. So we can run as well sum of X. Okay, X not found because I have not run these two lines. So I'm running these two lines, X and Y. So X and Y I have received in environment as well. Now if I run this line sum of X, see sum of X is 10. Okay, now I'm taking percentage. Now what will happen? Firstly, from X, 1 will come. In X, first element is 1. So 1 will come here and it will be divided by 10 into 100 means 10%. Next time 2 will come here, 2 divided by 10 into 100, 20%. In the same way, 3 and 4. And I'm holding all these percentages into a variable X percentage, X underscore PCT. So let me run these things. And what X underscore PCT percentage holds, let's see, 10, 20, 30, and 40. Okay. Why I am doing all these things? Because I want to create labels. I don't want A, B, C, and D. I want here that X, A is 10%, B is 20%. So now I will use concatenation. Concatenation in different object-oriented languages, concatenation means to add something, to add. And for add, we in Java, like we use plus sign, the symbol. But here we will use paste function. Paste function will add each and everything. So what I want to paste, the values at Y. What are the values? A, B, C, and D labels. And then we have equals to. I have given equals to in double quotes. Equals to will come as it is. If you don't want equals to and you want space, then just give space over here. Then I want values of XPCT, X percentage. What are the values? 10, 20, 30, and 40. And then at the last, I want the symbol, percentage symbol. So if I run this, and let's see what PCT holds. Now see A space 10%, B space 20%. If you don't want space, if you want to put equals to, you can put equals to. And if I run this, now see A is equal to 10%, B is equal to 20%, equals to. If you want any specific, character, like you want asterisk, you can put asterisk as well. It will come. Now see A asterisk 10, B asterisk 20. So you can use accordingly, according to your interest. Now I'm creating a pie chart. pie chart with values of x 1, 2, 3, 4. Now label will come as PCT. What PCT holds? This thing. So let me run this. Now see the graph. A asterisk 10, B asterisk 20. Okay, all this thing coming. Y asterisk is coming over here. Although I have written equals to, because I have not run this line. If I need to run this line, PCT, and now if I run, equals to will come. B is equals to 20%, A is equals to 10%. Now, in the same line of code, I'm adding colors as well to make my graph more beautiful. So colors will be red, blue, yellow, and green. Okay, so I have assigned these colors, and these colors will be allotted respectively. Red will be allotted to 10%, blue will be 20, 30, and 40. So let's see, run this. Red, blue, yellow, and green. And in the next line of code, I'm giving name to the graph. My beautiful pie. If I run, now see, my beautiful pie. So although this pie is not so much beautiful, but we can make it beautiful later on. Now, if you want this pie chart in 3D format, three-dimensional, for that you need a package called Plottex. So check whether you have that package Plottex. Yes, I have a Plottex, and I have called in from the library as well. So either you can write library Plottex, or you can click on this checkbox. Okay, if you want to see color combination, you can write this command display.viewer.all. It will show you all the color combination. Okay, so now to create 3D pie chart in the same line of code, only you have to add pie 3D as I've done over here, pie 3D. And remember, this D is in capital form, as R is our case sensitive language. So if I run this, now see, this is our beautiful pie chart, 3D pie chart. Okay, so let's see the scatter plot. We use a scatter plot when we have data, our data are quantitative in nature, and two or more than two variables we have. Not for the single one. We can use for single one as well, but if you want to see the correlation between two variables, in that case we use a scatter plot. So scatter plot will show you each and every data point. Okay, like in empty cars, if you want to see mileage. Okay, and to make a scatter plot, you have to write only plot. Create a scatter plot with mileage of empty car data set and type is equals to B. This what this B will do, it will add two data point with line. Okay, how? I'll show you. Run this. Now see, in empty cars we have 32 cars, 30, 31, 32. This is 32 observation. This is first observation. And these are data points, and these data points are connected with the help of a line. So this line is coming due to this B, which I have written type B. Okay. So right now I'm not using this iris dataset. We'll discuss it later on. Okay. So if I want to create mileage without the lines, now see, this is the dataset, mileage of the cars, and now line between these two data points are not coming. Why? Because I have removed this type is equals to B. Now, in this scatter plot, we can see these circles. What are these circles? These circles are my data points, but they are depicted with the help of this circle. But I can change these symbols. These are known as markers. We can change these markers. And by default in R, we have 1 to 24 different markers we can use according to our interest, any of them. So for one, if for to use marker, we can use command this one, PCH is equals to 1. If I run this, 1 is circle only. If I use PCH is equals to 2, now we have triangle. If you want your specific marker, in double quotes, you can write anything. Let us suppose I want X or I want asterisk. If I want asterisk, if I run this, Now see, asterisk will come as a marker. So there are different marker 1 to 24 provided. So you can use which one suits you. Now, if you want to increase the size of marker, increase or decrease the size of marker, you can use CEX. CEX is equal to 0.5. It will reduce the size of marker. We can see size is reduced. If I make it 1, it will become bold. Size will increase. And you can add in the last color as well. Red color. If you want blue color, you can type blue. So in this way, we have created a scatter plot. Now let's check with the whisker box plot. Now, what is this whisker box plot? This is one of my favorite plot because it shows you many things about your data set. Okay, it shows you the minimum value of the data set. It will show you the first quartile of the data set. It will show you median. It will show you third quartile, 75% of the data set, and the maximum value, maximum data point also. So, to create a box plot, you have to write only box plot, and I'm creating a box plot on mileage variable of MTCast dataset. So if I run this line, now see, this is my whisker box plot. So this upper line, this line of the whisker, this is the maximum data point. Maximum data point is 32 we have, okay? And this is the lowest data point, okay? This line of the box, first one is 25%, first quartile. The third, this line is above line is 75% of the data means third quartile. And this length of the box is interquartile range, 25 to 75. And this bold line in between is median. It is not mean, it is median. Okay. So if you want your box plot horizontally, you can do this. Horizontal is equals to, it will come horizontally. Now remember one thing, if the length of the total whisker box plot, observe and see the length of the box only, and the length of the total plot, total whisker. If length of the box is smaller, okay, in proportion, then your prediction power will be low. And if this length of the box is, if it covers maximum part of the overall plot, dotted lines, we have minimum dotted line, and the length of the box is very high. In that case, your prediction power will be higher. Okay. So this, the one thing which is very specific about box plot is it shows you the outliers in the data set. This is the only plot which depicts you outlier. Now, what is outlier? For example, let us suppose in an organization, the 95% of the employees are getting salary, let us suppose 50,000 per month. But there are few people in the organization, only few, those who are getting salary in lakhs or in crores or in millions, only few people, but maximum percentage of employees, they are getting salary 50, around 30 to 50,000 per month. Now if I take mean of that, what will happen? The mean will show around 2 lakh of each employee. Is this the true picture? No, because 95% people, they are drawing salary only 50,000, but only due to few people, those who are getting salary in crores, in millions, and that is why average is coming 2 or 3 lakh for each employee, which is not true. That is why we remove these people, those who are drawing salary in crores or millions, because they will influence my analysis. So I will not consider them, those data points, I will not consider in my analysis because they might influence my analysis, my plots, and I will remove them. And these data points are known as outliers. Now, how to check outlier? I have created a vector X with values 1 to 30, then 49 and 90 I have created. So if I run this X, let's see what X holds. Now see, X is having values 1 to 30. Then we have 49 and then 90. So if I run this, and now if I create a box plot using values of X vector, X and color will be below. Now this is the box plot. Now see, the maximum value it has considered is 30. The highest point it has considered is 30. 49 and 90, they are considered as outlier, not included in this analysis. Okay, if I make it 47, now what will happen? Will 47 will be considered as outlier or not? Let's check. Run. No. 47 is not considered as outlier. It was included in the plot. Now see the maximum length, maximum data point is, the value of maximum data point is 47. Okay. And 90 is considered as outlier. If I make it 48, and if I run these two lines and again create a plot, now see 48 is also considered included in the plot, in the graph. 90 is still as an outlier. I want to check at which stage it will consider as outlier. And so if I make it 49, now if I run and create a box plot, now see 49 is considered as outlier, although 48 was included in the graph. So this calculation of outlier is complex calculation, but Whisker box plot shows you the outlier in the data set, and it is a good practice. If you are doing some analysis, make a Whisker box plot of the data set and check if there are some outliers, remove them, because it might influence your analysis and it will not show you the real picture. Okay, so these are the 4 charts we have discussed right now. And in the next session, we will discuss other plots and other with iris dataset, and we will use ggplot, grammar of graphics. Thanks for watching.